Welcome. Today we're diving into the 5 clear signs you're on the right track when it comes to building strength, increasing muscle size, and improving endurance. This isn't just gym talk. This is rooted in neuroscience, physiology, and data-backed performance science. One of the most important principles in building strength, muscle size, and endurance is progressive overload. It's not just a concept rooted in bodybuilding culture. It's deeply grounded in how the nervous system and musculoskeletal system respond to stress. Progressive overload refers to gradually increasing the demand placed on your body during training. That demand can take many forms: more weight, more reps, more sets, shorter rest intervals, slower tempo, or even better control of the movement. At a physiological level, the reason progressive overload works is because our bodies are adaptive systems. When you apply a stimulus, let's say lifting a certain weight for a number of reps, you create small disruptions in the muscle fibers, metabolic systems, and even in your nervous system's firing patterns. In response to that disruption, the body works to rebuild itself stronger, more efficient, and more capable. But here's the critical part: that adaptation only occurs if the body perceives the current level of stress as slightly above baseline. In other words, if you're doing the same thing every week, your body doesn't have a reason to adapt. Progressive overload works on both a muscular and neurological level. When you lift heavier weights, you're not just challenging your muscles. You're training your brain and spinal cord to recruit more motor units. Essentially, you're teaching your body to access more of its muscular potential. This is especially important in the early stages of training, where much of the strength increase comes from improved neuromuscular efficiency, not just muscle growth. Over time, the body becomes better at synchronizing muscle contractions and stabilizing joints under load. But progressive overload is not infinite, and this is where a lot of people make a mistake. You can't keep adding 5 to 10 pounds every week forever. The nervous system is highly responsive, but it's also highly protective. When stress becomes too great, either in volume, intensity, or frequency, it activates defense mechanisms. These show up as chronic fatigue, poor sleep, elevated resting heart rate, or even decreased performance in the gym. That's why intelligent progression isn't linear, it's cyclical. The concept of cycling your training is often referred to as periodization. You deliberately structure your training in phases, some phases with higher intensity and lower volume strength, focused, others with moderate intensity and higher volume, hypertrophy, or endurance focused, and even some deload or recovery weeks. This isn't just about avoiding injury. It's about giving the body enough stimulus to adapt, followed by periods of lower stress that allow those adaptations to consolidate. Think of it like planting a seed and giving it just enough water and sunlight, then allowing it time to take root. One very effective method is to think in terms of 3-week cycles: 2 weeks of increasing intensity or volume, followed by 1 week of lower stress. During that lower week, you don't stop training. You simply reduce the overall load, either by lowering the weight, reducing total sets, or even focusing more on technique. This deload week gives the nervous system and muscles a chance to recover and supercompensate, meaning they come back stronger than baseline. This structure also reduces injury risk and psychological burnout, which are often overlooked but incredibly important for long-term success. It's also worth mentioning that progressive overload doesn't need to be aggressive. Many people think if they're not adding weight to the bar every session, they're failing. That's not true. Small, consistent improvements over weeks and months are what actually lead to meaningful long-term gains. This is especially relevant as people move beyond the beginner phase of training. The improvements slow down, but they don't stop, as long as the stimulus is still appropriate. And while the physical stimulus is important, recovery plays a crucial role in how well the body responds to that stimulus. Without adequate sleep, proper nutrition, and management of psychological stress, even the best designed overload program won't work. Recovery is not a passive process. It's where all the actual adaptation happens, where strength is built, muscle tissue grows, and endurance capacity improves. So, progressive overload is not simply about doing more. It's about doing more when the body is ready and knowing when to pull back to allow adaptation to occur. The most effective athletes and individuals training for longevity understand this balance intuitively or through deliberate tracking. If you want to build strength, size, and endurance that lasts, and that supports mental and physical performance across your lifespan, then your training must evolve intelligently. Progress should be pursued, but never blindly. Would you like the remaining 5 points expanded in this style as well? When people think about training for strength, muscle growth, or endurance, they often default to focusing on how much weight they're lifting or how many reps they're performing. But one of the most overlooked aspects of training, and one that significantly affects the nervous system, muscle development, and even tendon resilience, is the type of muscle contraction being used. There are 3 primary types of muscle contractions: concentric, eccentric, and isometric. Each engages the nervous system and musculature in unique ways, and each plays a distinct role in adaptation. A concentric contraction is when the muscle shortens while producing force. For example, when you curl a dumbbell up during a biceps curl or press the barbell up during a bench press. This is typically what people think of as the work phase of the exercise, and it's essential for power and acceleration. From a nervous system perspective, concentric contractions are efficient at training motor unit recruitment and explosive movement. But they're not the most effective at stimulating muscle growth or connective tissue adaptation. An eccentric contraction, on the other hand, is when the muscle lengthens under load. Think about lowering that same dumbbell slowly back down after a curl, or descending into a squat. This phase creates more mechanical tension across the muscle fibers and connective tissue than concentric movement alone. The nervous system has to work harder to maintain control, especially under slow tempos or heavy loads. Eccentric contractions are known to cause more muscle fiber microdamage, which sounds negative, but in controlled doses, it's exactly what triggers repair and hypertrophy. It also stimulates the development of type Roman, 2 muscle fibers the fast, which fibers responsible for power, size, and speed. Then there's the isometric contraction, where the muscle is under tension but there's no change in length. Holding a plank, pausing halfway through a squat, or bracing under a heavy deadlift are examples. These moments might seem static, but the neural drive during isometric holds is intense. The brain has to fire signals to keep the muscle activated without movement, which increases motor control and endurance. Isometrics also strengthen joints and connective tissues, making them more resilient to injury, especially under high loads or in sports where sudden stops and changes in direction are common. What's critical here is that these 3 types of contractions don't exist in isolation. In almost every movement, all 3 are present to some degree. But in most standard training programs, one is emphasized, usually the concentric phase. People tend to lift the weight quickly, then drop it or passively let gravity bring it down, essentially neglecting the eccentric. They also rarely pause at any point in the movement to develop isometric control. From a neural plasticity standpoint, this is a missed opportunity. The motor cortex and spinal circuitry involved in voluntary movement are highly responsive to novel stimuli. When you train across all 3 contraction types, you activate different neural pathways and engage a broader network of motor units. This enhances overall control, precision, and strength. It also improves proprioception, your brain's ability to sense where your body is in space, which directly benefits athletic performance and injury prevention. Integrating all 3 into a training program doesn't have to be complex. It can be as simple as slowing down the eccentric phase of each rep, for example, taking 3-5 seconds to lower during a pull-up, or adding a 2-3 second isometric pause at the bottom of a squat to eliminate momentum and force full muscular engagement. These variations increase time under tension, which is a key driver of hypertrophy and metabolic stress, especially when training with submaximal loads. One interesting aspect of eccentric training is its ability to increase muscle strength at a faster rate than concentric training alone. Studies show that eccentrics generate more force with less metabolic cost. That means you can overload the muscles more effectively while reducing systemic fatigue. This has implications not just for hypertrophy, but for injury rehabilitation, tendon remodeling, and even age-related strength loss. In fact, eccentric training is increasingly used in clinical settings for patients recovering from musculoskeletal injuries, because it enhances structural adaptation without requiring maximal cardiovascular effort. The takeaway is this: to build comprehensive long-term strength and resilience, you must deliberately engage all three muscle contraction types, not just because it creates more muscular growth, but because it trains your nervous system in a broader, more functional way. This doesn't just make you stronger in the gym, it makes your body more adaptable in real-world conditions. When we think about training, we need to expand the conversation beyond just sets, reps, and weight. We should be asking, how am I loading the movement? Where am I applying tension? And what kind of control am I building neurologically? Training with all three contractions in mind turns each rep into a complete neural and muscular stimulus, not just a task to be checked off. And that's the level of detail required for lasting physical transformation. Would you like the next one? Key point 3, expanded as well in this style. One of the most reliable signs that your training is effective, whether for strength, hypertrophy, or endurance, is not necessarily the amount of weight you can lift in the gym, but how your body performs outside of it. In neuroscience, we often refer to this as transfer, the ability of a learned or trained capacity to apply across different contexts. When training is well structured and biologically aligned, it enhances not only specific motor outputs in the gym, but also improves how you move, react, and resist fatigue in daily life. This concept is grounded in how the central nervous system adapts to physical training. Strength, for example, isn't just about building bigger muscles. It's about improving how your brain communicates with your muscles. That communication occurs through a process known as motor unit recruitment. A motor unit consists of a motor neuron and the muscle fibers it innervates. When you train, particularly under heavy or unstable conditions, your nervous system becomes more efficient at activating these motor units. You start recruiting more of them, and you do so faster and with more synchronization. What that means, practically, is that the force you produce becomes more coordinated, more precise, and less taxing over time. So suddenly, tasks like carrying heavy groceries, climbing stairs, lifting your suitcase into the overhead bin, or even playing a pickup game of basketball start to feel easier. You might not even notice the change immediately. It often manifests as a kind of subtle confidence in your body's capabilities. Movements feel smoother, more controlled. You feel grounded in your physical space. That's a neurological adaptation as much as it is a muscular one. There's a fascinating interplay between the muscular and neural components of strength and endurance. When you perform a compound movement like a squat or a deadlift, you're not just targeting specific muscles, you're coordinating multiple systems. Balance, core stability, breathing mechanics, joint alignment, and even visual focus. If that training is effective, it generalizes. You start to exhibit better posture while sitting or standing, improved joint tracking while walking or running, and more efficient movement under fatigue. One of the ways we can measure the effectiveness of strength and endurance training is by looking at the functional carryover. For instance, if you've been training your posterior chain glutes, hamstrings, and spinal erectors, you might notice that standing for long periods becomes easier. Your lower back doesn't fatigue as quickly. If you've been developing grip strength and upper back stability, you may find that carrying bags or doing manual labor feels significantly less taxing. This kind of general adaptation is often missed in traditional training conversations because we tend to isolate variables, sets, reps, loads, but the nervous system doesn't operate that way. It's constantly integrating inputs, proprioceptive feedback, visual cues, vestibular signals, and mechanical stress. A training protocol that accounts for this complexity by emphasizing good movement patterns, coordination, and variability will always produce better outcomes outside the gym. Another important factor here is endurance. True muscular endurance isn't just about doing high reps. It's about the ability of your muscles and cardiovascular system to sustain output over time without breakdown in form or function. And again, one of the clearest signs that your endurance training is working isn't just a faster 5K or more reps on the bike. It's how quickly you recover between efforts, how long you can stay physically active before fatigue sets in, and how quickly you return to baseline. If you walk long distances or do a physically demanding task and recover in minutes instead of hours, that's your training working. There's also a psychological component to this. As you train, your brain becomes more confident in your body's capabilities. This is called interoception, your ability to sense the internal state of your body. When interoception improves, you become more attuned to fatigue levels, posture, effort, and breathing. You don't just perform better, you feel better doing it, and that confidence spills over into how you approach physical tasks in general. So when you notice that you can move through life with more ease, lift things more confidently, recover more quickly, or even just feel more capable walking up a hill or sprinting to catch a bus, those are not minor wins. Those are signs that your training is neurologically integrated and functionally useful. They are signs that your brain and body are adapting in unison, which is ultimately what all good training should aim for. Progress in the gym is important, but transfer beyond the gym, that's the real test. If you can move better, feel stronger, and endure more in everyday life, your training is doing exactly what it's supposed to do. Would you like to continue with point 4, expanded in this style next? Sleep is not a passive state. It's an active, highly orchestrated process in which the brain and body undergo essential repair and adaptation. For anyone training to build strength, muscle size, or endurance, sleep is arguably the single most important recovery tool, and yet it's often neglected in favor of more training volume. Supplements or advanced techniques, but the reality is, without consistent, high-quality sleep, the physiological adaptations you're trying to create simply won't occur. From a biological standpoint, training provides the stimulus, but recovery, and especially sleep, is where the adaptations take root. When you sleep, particularly during deep slow, wave sleep and rapid eye movement REM phases, your body initiates a cascade of recovery processes. Growth hormone is released in its highest concentrations during the first few hours of sleep. This hormone plays a critical role in muscle repair, tissue remodeling, and fat metabolism. Testosterone levels, critical for strength, energy, and tissue repair, are also regulated heavily by sleep duration and quality. Research shows that even modest sleep restriction, reducing sleep from 8 to 6 hours per night, can significantly impair muscle recovery and reduce strength gains. One study found that individuals sleeping less than 6 hours per night had markedly lower levels of anabolic hormones and elevated cortisol, a catabolic hormone that breaks down tissue and increases fat storage. Over time, these hormonal imbalances blunt hypertrophy, reduce training performance, and increase the likelihood of injury. The nervous system is also deeply affected by sleep. One of the primary goals of training is to improve neural efficiency, how well your brain can communicate with your muscles. This is especially true for strength training, which depends heavily on the brain's ability to recruit motor units rapidly and in a coordinated manner. But sleep is where synaptic pruning, consolidation of motor learning, and resetting of neuromuscular pathways take place. Without sufficient sleep, reaction time, coordination, and force production all decline. Even endurance is impacted by poor sleep. Mitochondria, the energy-producing units of your cells, require rest to recover and proliferate. Sleep deprivation reduces mitochondrial function, lowers VO2 max, and increases the perceived effort of physical tasks. So when people say they're tired during a workout, it's not just psychological. The metabolic systems that generate energy are functioning less efficiently when sleep is restricted. Recovery, however, is not only about sleep duration, but also about quality and timing. The body operates on a circadian rhythm, a roughly 24-hour cycle governed by light, temperature, food intake, and activity. Training that aligns with your circadian rhythm tends to produce better adaptations. For example, training in the late afternoon when body temperature and grip strength naturally peak often results in better performance. But regardless of when you train, consistency in sleep timing, going to bed, and waking up at the same time each day has a profound impact on your body's ability to recover and adapt. One tool to improve sleep quality is to manage light exposure. Early in the day, getting sunlight in your eyes, especially within the first 30-60 minutes of waking, helps set your circadian rhythm and increases wakefulness, promoting neurotransmitters like dopamine and norepinephrine. In the evening, reducing exposure to artificial light, particularly blue light from screens, allows melatonin in production to rise, which is critical for initiating sleep. This is not just theoretical. Small changes in light exposure can have measurable effects on sleep latency, how fast you fall asleep, sleep depth, and next-day performance. Another key factor is managing autonomic balance, how the body shifts between sympathetic, alert, and parasympathetic, rest and digest states. Training, particularly high-intensity work, activates the sympathetic nervous system. That's necessary during exertion, but becomes problematic when it's chronically elevated. To shift into recovery mode, techniques such as breathwork, mindfulness, and even low-intensity, aerobic activity like walking can help promote parasympathetic activity and prepare the body for deeper recovery during sleep. Nutrition also intersects with sleep. Avoiding high sugar or heavy fat meals late at night can prevent disruptions in blood glucose that fragment sleep cycles. On the other hand, consuming foods rich in tryptophan, magnesium, and complex carbohydrates can help facilitate serotonin and melatonin in synthesis, promoting sleep onset. Ultimately, recovery is not something to be tacked on to a training program. It is the training program. Training breaks you down. Recovery builds you back up. Without sleep, all the hours you spend in the gym are diminished. With it, each session becomes more effective, your mood stabilizes, your performance improves, and your risk of injury goes down. If you're serious about strength, muscle, and endurance, then prioritizing sleep isn't optional, it's fundamental. Would you like to move on to expanding Key Point 5 in the same style? One of the most underappreciated tools in strength, hypertrophy, and endurance training is the deliberate cultivation of what's commonly known as the mind-muscle connection. At a glance, this may sound like science or gym folklore, but when we look closely through the lens of neuroscience, the concept becomes very real and incredibly powerful. The mind-muscle connection is a form of focused attention, often called internal cueing in exercise science. Instead of simply performing a movement, you direct conscious awareness to the muscle you're trying to recruit. For example, during a row, you intentionally focus on contracting the lats rather than just moving the weight from point A to point B. What this does, neurologically, is enhance the quality and precision of neural signaling to the motor units that control that specific muscle. The motor cortex of the brain, specifically the region responsible for voluntary movement, can increase its output when attention is focused on a specific muscle group. This isn't hypothetical. Studies using electromyography (EMG) have shown that when individuals focus mentally on a muscle during contraction, they actually activate more motor units in that muscle. In other words, the brain becomes more efficient at recruiting the exact fibers necessary to produce force, and does so more selectively. This has huge implications for hypertrophy. Muscle growth occurs not simply because a load is moved, but because mechanical tension is applied across the muscle fibers over time. If the tension is being spread across multiple muscles, or if prime movers aren't fully engaged, you dilute the stimulus. Over time, This can lead to imbalanced development, stalled progress, or even injury. But when you focus on contracting the target muscle deliberately and consistently, you create a more potent training signal. It's not just about load, it's about neural precision. This type of neural training also plays a role in endurance. When you're performing repetitive contractions under fatigue, the ability to maintain motor control becomes crucial. That control is sharpened through deliberate attention. In fact, elite endurance athletes often exhibit superior neuromuscular coordination, not just bigger lungs or stronger hearts. They're able to recruit muscles with just enough force to be efficient, conserving energy while maintaining form. That's a high-level version of the same principle. Over time, training the mind, muscle connection results in what's called motor pattern consolidation. Your brain becomes better at firing the right muscles at the right time with less effort. This is how athletes can appear smooth and powerful while operating under extreme stress. They've trained their nervous system, not just their muscles. This also helps reduce compensatory movement patterns where surrounding muscles take over for weaker ones. That kind of compensation often leads to chronic pain or injury. Training this connection requires practice. One method is to begin with lighter loads and slower tempo to increase the amount of sensory feedback your brain receives. When movement is slow and controlled, you have more time to feel what's happening, more input to the somatosensory cortex, the part of the brain that maps the body. You can literally refine your internal map of the muscles you're training. That leads to more precise motor output in future sessions, even when loads increase. Breath control also plays a role here. Breath and attention are tightly linked in the brain. If your breathing is shallow and erratic, your focus tends to drift. But when you breathe deliberately, especially nasal breathing through full diaphragmatic cycles, you engage brain areas responsible for self-regulation and interoception, including the insular cortex. This strengthens your ability to stay focused on muscle contraction and form under stress. There's also a feedback loop between attention and reward. When you feel a muscle working in a targeted, controlled way, the brain releases small amounts of dopamine, not the kind that spikes and crashes, but the kind that reinforces behavior. Over time, this builds intrinsic motivation, which is far more powerful and sustainable than extrinsic motivation like appearance or numbers on a barbell. You begin to enjoy the process because you feel your body learning and responding. That's the hallmark of lasting adaptation. Importantly, this kind of focus training doesn't replace traditional measures of performance like load, volume, or progression, but it enhances them. A strong mind, muscle connection allows you to get more out of each rep, more feedback from each set, and greater returns over time with less wasted effort. It makes training a dialogue between brain and body, rather than just an output task. In the long term, cultivating this connection builds not only better performance and aesthetics, but a stronger sense of agency over your body. You become more embodied, more aware of how your brain controls physical movement and how movement feeds back into mental state. That loop is powerful. It improves not only how you train, but how you move through the rest of your life. Would you like me to summarize or expand further on any of these 5 key points? Progressive overload is one of the foundational principles in all forms of physical training. To increase strength, build muscle, or enhance endurance, the body must be consistently challenged beyond its current capabilities. This is how adaptation works through a process called homeostatic disruption. You stress the system, it responds by remodeling tissues, enhancing neural pathways, and building greater capacity to handle similar stress in the future. But overload doesn't mean constantly pushing to failure or lifting heavier in every session. In fact, doing so too frequently can create more harm than benefit. The key is not just to apply progressive overload, but to apply it intelligently. That means understanding how the nervous system, muscular system, and endocrine system adapt to intensity and fatigue over time. It also means recognizing that recovery and modulation of intensity are not signs of weakness. They're fundamental parts of long-term performance and health. Let's start with the brain. The central nervous system plays a gatekeeping role in all physical output. The motor cortex initiates voluntary movement, and descending pathways coordinate activation of spinal motor neurons, which then recruit muscle fibers. High-intensity training, especially heavy lifting or sprinting, places significant demand on these neural circuits. It also activates the sympathetic nervous system, which prepares the body for maximal effort but also increases systemic stress through cortisol release, elevated heart rate, and heightened alertness. This sympathetic activation is necessary at times, but if it's not balanced by sufficient recovery, or if it's applied too frequently without variation, it begins to desensitize the very system you're trying to train. That's when you start to see symptoms like reduced performance, irritability, persistent fatigue, or poor sleep, classic signs of central nervous system overreaching. This is why cycling intensity, also known as periodization, is so essential. Cycling intensity works by alternating high-stress training blocks with periods of lower intensity or volume. These lighter periods aren't just for rest. They allow the brain and body to consolidate adaptations. They also give tendons, ligaments, and joints time to remodel and recover. Unlike muscles, which are highly vascular and recover quickly, connective tissues adapt more slowly. Without deload phases or variation in loading strategies, these tissues can become the weak link, leading to injury. From a neuroplasticity standpoint, variation in intensity also prevents habituation. The brain responds most strongly to novelty and challenge, but not constant overload. By introducing phases where reps increase, load decreases, or tempos change, you're providing fresh stimulus without always having to increase the weight on the bar. This supports motor learning, coordination, and retention of skill. There are also hormonal implications to consider. Intense training elevates anabolic hormones like testosterone and growth hormone, but only when managed well. Chronic high-intensity output with insufficient recovery can lead to chronically elevated cortisol, suppressed immune function, and reduced testosterone levels. That state not only halts progress, but increases the likelihood of overuse injuries and poor mental focus. Practically, intelligent cycling of intensity can take several forms. A simple and effective strategy is to train in 4 to 6 week blocks where you gradually increase load or volume over 3 weeks, then reduce intensity by 40–60% for 1 week to allow recovery. Alternatively, you can use daily undulating periodization, varying intensity and volume within a single week. For example, a Monday heavy strength day, Wednesday medium volume, and Friday high rep endurance or hypertrophy session. This keeps the nervous system stimulated while minimizing systemic fatigue. Autoregulation, adjusting intensity based on how you feel, is another tool. This relies on developing interoceptive awareness, paying close attention to sleep quality, energy levels, motivation, and physical feedback. On days when you feel mentally and physically dialed in, you can push closer to max effort. On days when you're under-recovered, lower the weight, increase rest periods, or shift to skill-based or accessory work. This isn't soft training, it's strategic use of recovery science. It's also worth mentioning that some of the strongest and most resilient athletes train submaximally for much of the year. They stay in the range of 70–85% of their max and focus on technical precision, tempo control, and repeatability. They build up layers of structural and neurological resilience before attempting maximal efforts. That kind of long-view thinking is essential for anyone looking to maintain progress over years rather than months. So while progressive overload remains non-negotiable for building strength, size, or endurance, the method of progression must be dynamic, not linear. Load isn't the only variable. You can manipulate rest periods, frequency, movement velocity, time under tension, or movement complexity. When you vary stimulus intelligently and cycle intensity in alignment with your recovery capacity, You create a training environment that fosters growth, preserves health, and optimizes neural engagement. Ultimately, the best training protocols aren't the most intense, they're the most sustainable. The nervous system thrives on challenge followed by recovery, not relentless strain. Progress comes not from pushing harder every session, but from knowing when to push and when to adapt. Would you like a compiled version of all 6 points as a speech or document next?